Quadratic equation is given by ax square plus bx plus c, and we know that the methods to solve a quadratic equation are: number 1, factorization; number 2, it is completing the square method, factorization; number 2, it's completing the square method; and number 3, we have the formula. So today we will be discussing the importance of the formula, and the formula to solve a quadratic equation is x is equals to minus b plus minus under root b square minus 4ac divided by 2a. Now from this formula, the b square minus 4ac holds a great significance. B square minus 4ac holds a great significance, and it is actually called the discriminant of the quadratic formula. B square minus 4ac, this is called the discriminant of the quadratic formula. Now the quadratic formula, it depends on the condition of b square minus 4ac. If this b square minus 4ac comes out to be greater than 0, then we say that there are two distinct real roots of the equation. If b square minus 4ac comes out to be equal to 0, then we say that there are equal roots or one repeated root of the equation. And if this discriminant b square minus 4ac comes out to be less than 0, then we say that there are no real roots to the equation. So what does this mean graphically? Let's discuss that now. So let's discuss the significance of the quadratic curve with respect to the x-axis. Now in the first case, we can see that there are two distinct points where the quadratic curve is intersecting the x-axis. This is only possible if your discriminant b square minus 4ac comes out to be positive, or it comes out to be greater than 0, giving us two real and distinct roots. If the quadratic equation, second case, if it is intersecting the x-axis at just one point, then this is the condition for which we say that this b square minus 4ac is equal to 0, and we are going to have here equal or one repeated root. And the third case is that if this discriminant b square minus 4ac comes out to be less than 0, then less than 0 means that in the quadratic formula we have this b square minus 4ac within the under root sign, therefore less than 0 meaning negative, under root negative not being possible. We can say that the significance is that the curve is not at all intersecting the x-axis and there are no real roots to the quadratic curve and the x-axis here. So this is what we mean graphically when we are solving with respect to the discriminant. The discriminant, again I will say, it holds a great importance, great significance to tell us about the roots of the quadratic curve with respect to the x-axis. So let's solve some examples, some questions to see or understand this discriminant more clearly. Determine whether each equation has two distinct roots, equal roots, or no real roots. So just if we have this quadratic equation which is 2x squared plus x minus 2, we know that the a value is a 2, b is the coefficient of x, therefore it's a 1 in this case, and c being the constant is a minus 2. I need to find out the discriminant value. That means I need to have b square minus 4ac. Substituting that, I can say it's 1 the whole square minus 4 times 2 times negative 2, and I can see this is going to be a 1 plus 16, and I can see that this value is greater than 0. So just with respect to this condition, the value that I have, I know that there are going to be two real and distinct roots with respect to this equation here. In the same way, if we have another equation, and let's say that this equation is 4x squared plus 5x plus 2, which is equal to 0, again, I need to determine whether there are two distinct roots, equal roots, or no real roots to the equation. So let's again find the discriminant, and the discriminant is with respect to a as 4, b as 5, and c as a 2, b squared minus 4ac. Let's find the discriminant. This is going to be 5 the whole square minus 4 times 2. That will give me a 25 minus 32. And I can see that my answer is going to be a negative, which is less than 0. I know that it's a negative 17 less than 0. Therefore, there are going to be no real roots to the equation. And graphically, what we mean is that to this quadratic curve, the x-axis and the quadratic curve, they are not intersecting with each other. Let's do the third case, and let's say that the third case is for 4x squared minus 12x plus 9, which is equal to 0. A value is a 4, B value is a negative 12, and C value is a 9. So again, substituting the values in the discriminant, it should be negative 12 the whole square minus 4 times 9, or I can say it's a 144 minus a 144, which comes out to be equal to 0. And this means that there is equal or repeated root, or one repeated root for this equation. Graphical curve is actually a tangent to the x-axis. So this is how we can determine the nature of the quadratic curve with respect to the x-axis. So solving another question. From here, I know that the values of a for less than 0, again we can see that we are talking about the condition which is less than 0. So for less than 0, the inequality is always a continuous range. So I can say that my inequality is minus 8 less than a, which is less than a positive 8. So this is the range of values of a which can be solved, giving us no real roots to the equation. So another example, if 6 minus 2x minus kx squared is equal to 0 has a repeated root. So the keyword again is a repeated root. Find the value of k. So repeated root, we know that the condition for the discriminant needs to be b squared minus 4ac, which should be equal to 0. Therefore, from the equation that I have, I can see that this is 6 minus 2x minus kx squared, which is equals to 0. Or rearranging them and taking out the negative common, I can say it is kx squared plus 2x minus 6, which is equal to 0. And obviously, I'll be left with kx squared plus 2x minus 6 equals 0. Now, substituting all the values in the discriminant, it's going to be 2 the whole square minus 4 times k times a negative 6. This needs to be equal to 0. So 4 is equals to 4 plus 24k is equal to 0. Or I can say it's 4, which is equals to a negative 24k, or k is equals to negative 1 by 6. So for k to be equal to negative 6, the discriminant should be equal to 0. And I know that for this case, the k value needs to be negative 1 by 6. The quadratic equation kx squared plus 5x plus 2 equal to 0 has two distinct real roots. Find the range of possible values of k. Again, underline the keywords. It has two distinct real roots. So we need to find the range of possible values of k. So solving that, we know the condition, and the condition states that the b squared minus 4ac, the discriminant, has to be greater than 0. Now, one thing is very much clear here, and that is that there are two distinct roots to the equation. So b square minus 4ac comes out to be greater than 0. Our quadratic equation was kx square plus 5x plus 2 is equal to 0. So if I substitute the values in the discriminant, I know that it should be 5 square minus 4 times k times 2, which should be greater than 0. Or I can say it's 25 minus 8k, which should be greater than 0 here. Or I can say it's 25 greater than 8k. Or I can say it's 25 greater than 8k, or 25 by 8 is greater than k. Therefore, I can say that k should be less than 25 by 8. So this is the set of values of k, or the range of values of k, for which the quadratic curve will be having two distinct real roots. So prove that the quadratic equation q minus 5 bracket x square plus 5x minus q equals to 0 has real roots for any value of q. So the key roots that we need to understand here is that the quadratic equation should be having real roots for any value of q. So real roots, now this real root, it combines the two conditions where we say that the equation, quadratic equation, can have two distinct real roots, and also it can have one equal real root or just one repeated root. So if I combine the first two conditions where the quadratic curve might be intersecting the x-axis at 2 points, or it can be a tangent to the curve. So combining the two conditions, because the condition in the question says that the roots are real, they haven't described if there are two real roots or there is just one repeated root. Therefore, I will combine the two equations and I will say that the discriminant b square minus 4ac will be greater or equal to 0. So the quadratic equation that is given is q minus 5x square plus 5x minus q equals to 0. Substituting the values for b, it's a 5 the whole square minus 4 times q minus 5 times minus q, which is greater or equal to 0. I can say that this is a 25 plus 4q and q minus 5, which should be greater or equal to 0. Or I can say that this is a 4q square minus a 20q plus 25, which is greater or equal to 0. I have only arranged the equation in proper quadratic form. Now from here, what I have observed is that the first term is a perfect square. The third term is also a perfect square. So that in between, I can say that I'm basically having 2ab, which is 2 times 2q times 5. I'm just solving them with respect to the quadratic equation, which says that it is a minus b the whole square, which is equals to a square minus 2ab plus b square. So this equation then can be written in the form which is 2q minus 5 the whole square, which should be greater or equal to 0 here. So 2q minus 5 the whole square. Now the whole square shows that for any value of q that I am going to substitute here, any value of q, the 2q minus 5 the whole square will always be a positive or greater or equal to 0. Therefore, it shows that there has to be real roots to the equation for the values of, for any value of q that can be substituted here. So I'll just write that therefore for any value of q, for any value of q, 2q minus 5 the whole square will always be positive, giving us real roots. Therefore, for any value of q, 2q minus 5 the whole square will always be positive, giving us real roots, and therefore it's proved that for any value of q, the quadratic equation will always be having real roots here. So the equation px squared plus qx plus r equal to 0, where p, q and r are constant, has roots. Let's underline. They have roots negative 1 by 2 and 3 by 4. They have roots negative 1 by 2 and 3 by 4. Find the smallest possible integer values of p, q and r. So for such questions, the roots are given. Therefore, we can say that x is basically equal to a negative 1 by 2, and I can also say that this x equals a 3 by 4. If I just bring it to the factorized form, I can say it's x plus 1 upon 2 and x minus 3 upon 4, which should be equal to 0 here. Solving them, I can say it's an x squared minus 3 by 4x plus 1 by 2x and a minus 3 over 8, which is equal to 0. Solving it further, I can say that the equation is going to be x squared minus 1 by 4x minus 3 by 8, which equals to 0. And taking the LCM, it's 8x squared minus 2x minus 3, which equals to 0. So if I compare it with the given equation, which was px squared plus qx and plus r, which is equals to 0, comparing the coefficients of x squared, I can say that p should be equal to q. Comparing the coefficients of x, I should say that q equals a negative 2, and comparing the constants, I can say that r is equals to negative 3. So these are the values of the integers p, q and r. These are the values